Hi all, thanks for watching this video. Welcome to Introduction on Hive. So in this video we are going to see very thoroughly what is Hive, what was the purpose of having the Hive in our big data world, and where it's going to fit. Okay, when you have our HDFS and MapReduce, why Hive was introduced, and what and all advantages that you are going to see when you are going to have your Hive in as a your processing component in your organization. And at the end we are going to see as the architecture how it is going to work out. We are going to see very thoroughly. Let me go ahead and introduce what is Hive actually. Hive is a data warehousing, or it's a tool on top of the which is built on top of the Hadoop, which can be used as a data summarization for easy data analytical queries and also for the reporting purpose. This is the definition, so you don't have to worry about this one if you did not get anything out of this one. Let's go ahead and discuss where Hive is going to lie in our Hadoop ecosystems. Then I'm going to just come back to this definition actually. So as you know here, very simple thing here. Let me go ahead and just draw the simple diagram here. So this is your HDFS file system. So what is HDFS file system? It's a space where you are going to distribute your data into the multiple computer. This is your HDFS file system. And then you have one more this thing, the processing components, MapReduce. So MapReduce is the processing component where you can just run the data that I have stored in your HDFS file system. We know that one. This is your HDFS. Okay, and this is going to be the MapReducing actually. Okay, so now these are the two components. They were born with our Hadoop when Hadoop was born. We know that one. That part is very clear. But as you know, MapReduce is a framework. It's a paradigm. It's a technique where you have to take the help of one of the programming language to write your MapReduce program. It can be Java. It can be Python, it can be Ruby on Rails, it can be C++. One of these programming techniques you have to use in the MapReduce framework, then only your MapReduce program is going to work it. As you know, that is the main reason why they had to think the alternative ways to process your data that you have distributed across the HDFS file system. Because people who knows about Java and Java kind of technologies in the market are very less actually. So that is the reason people who are already started using almost decade back when Hadoop was born, when they started using the MapReduce program, just forget about writing the new programs. People who are just maintaining the existing programs also, okay, they are having lot many challenges actually. For that reason only they just start thinking about the alternative ways here. So one among the solution out of that one is going to be the Hive actually. So Hive is going to just stay on top of the MapReduce. It's an alternative abstraction which is really built on top of the MapReduce programming actually. Okay, so now here is Hive is going to be here actually. So now you can see very clearly Hive is going to use two core components. One is going to be the HDFS and as well as the MapReduce program. So what will happen here is we are going to create one extra layer on top of your HDFS file system. That is the reason we said like it is a data warehousing tool. So basically when we are going to use our warehouse, whenever you just probably you extract from your data from the different databases and you apply some of the transformations, then the final data whatever you see, that is what you are going to dump into your warehouse actually. So once you dump the data into the warehouse, you can just go ahead and create the reports, you can analyze the queries, and you can simply just fire the queries on top of that. You can see lot of insights out of the data actually. Exactly, that is what it is going to provide for us from our big data world. Hive is the one who is going to provide that infrastructure for us actually. So when you are going to put the data here, the data will be again stored in the HDFS file system, but it will be in a structured way actually. It is a kind of the warehouse. Okay, so you have to understand it has to using both HDFS and MapReduce both for our processing component. The next thing is going to be Hive is same as your SQL. Okay, so Hive is same as SQL. The main intention of introducing the Hive is only people who are having the some of the SQL knowledge, they can go ahead and write the simple Hive queries, then they can be converted into the series of MapReduce program. These MapReduce programs are going to work on top of the HDFS file system. That is the real definition of your Hive actually. Hive is a, again I'm repeating here, the definition of a Hive. Hive is a data warehousing tool which is built on top of the Hadoop, which can be used as a warehousing from our big data world actually. So Hive is going to use both MapReduce as well as HDFS, both for its storage purpose, for its processing purpose actually. That is what exactly where Hive is going to lie actually. Let's go ahead and see the next topic actually. Okay, the next thing is going to be, instead of writing the, as you know, that is the definition, instead of writing the complex MapReduce programs here, simply you are going to write our Hive queries that will be converted into series of MapReduce program. We have seen with our discussion actually. So in Hadoop we are going to use both storage and as well as processing technologies. We have discussed that one very thoroughly just now. The next thing is going to be, it uses HDFS to store its underlying big data and MapReduce to process the stored data. That is what exactly we have seen in this diagram actually. HDFS and MapReduce both will be used for this purpose actually. Okay, the next thing is going to be, who was developed Hive initially? Hive was developed initially the Facebook. They are the one who started thinking this way, and later on Apache Foundation took as a full-time project, and it named its project name as a Apache Hive actually. So Facebook is the one who has introduced earlier with the Hive actually back in 2007-8. Okay, then Hive architecture. So what Hive is going to follow, and what and all ways we can trigger the Hive queries so that it will work on top of the HDFS file system and the top of the MapReduce program. So as you know, there are some different ways where you can just trigger your Hive queries actually. You can talk to your Hive engine. This is going to be your Hive engine. Basically this is the Hive core part, this one. So using three ways where you can talk to your Hive actually. One is going to be the CLI, command line interface, CLI. So simply you can just go ahead and open one command line interface, and you can just go ahead and key in your queries, and that will be converted into series of MapReduce program. Or you can just go ahead and use the web interface actually. So what I mean by web interface is very simple. You are going to just open one URL, and in that you are going to just put it your queries, and those will be converted into series of MapReduce program by just sending that one to this engine actually. The third one is going to be the thrift server. So using your JDBC and ODBC remotely, you can just go ahead and fire your queries, and that will be just working on top of the Hive core actually. That is going to be the next thing. So these are the three ways where you can just trigger our Hive queries, and you can talk to our Hive engine. So now what is this driver actually? Driver is the one who is going to play the vital role in our Hive architecture actually. Driver is the one who is going to interact with our clients. Driver is the one who is going to interact with our HDFS file system. Driver is the one who is going to interact with our MapReduce also. So let's go ahead and see how it is going to behave. So driver is the one, first and foremost thing, irrespective of whether you are going to trigger your queries from CLI, from ODBC, JDBC remotely, or probably from your Hive web interface. Irrespective of that, first and foremost thing, the query that you have fired, that will be analyzed, that will be taken care whether is there any user errors in that will be taken care by the parser actually. Parser is the one who is going to just make it very clean query, whether it is having any syntax error, user error, and once that is passed, that will be passed to the optimizer. Optimizer is the one who is going to, basically when you are going to run as a script, it's going to optimize your query automatically. Optimization is nothing but wherever So some programmers probably, if you have, they have, instead of running your query at the beginning of the stage and you have running at the entire or later stage, if you're running in that case, instead of just throwing your running your data, flowing your data from top to bottom, basically your optimizer will come into the picture, I would say, in the filters actually. So probably out of your 1000 employees, people who are having, just your use case is going to maybe people who are going to be particular location actually, but the particular location, out of the 10,000 employees, only 1000 employees are there. But instead of filtering your data in the starting stage, if you are filtering at end, indirectly you are going to just, instead of processing your 1000 records, you are processing the 10,000 records till end actually. That is not the good way of doing that one, because your high query is going to take more time to process. That is the reason it's going to optimize automatically. Instead of just filtering at the end, you're going to filter at the starting only. That is going to, the optimizer is the one who's going to do. The next thing is going to, it's going to create the execution plan actually. The planner is the one who is going to create the one or more the sorted MapReduce programs, which means how many MapReduce programs can be triggered on top of this Hive actually, based on your high query, the nature of the query, whether you are using joins, you are using where clauses, you are using having clauses, all those things. Your planner is the one who is going to just trigger, or who is going to decide, okay, these many MapReduce programs are going to be triggered. Once that is done, we are going to just hand over to the execution engine actually. Execution engine is the one who is going to create completely the MapReduce programs, and that will be handed over to the our Hadoop framework actually. So whenever I say Hadoop, in the sense, it is going to just trigger whatever the MapReduce program that we have added, that will be handed over to the resource manager, which means MapReduce program is nothing but the resource manager. The resource manager is the one who is going to go continue, and it's going to just work on top of the HDFS file system, whatever we have provided. This is what exactly in our Hive is going to work out. So once you are done with your process, that required output can be again dumped into our another Hive table, or you can just go ahead and store into the HDFS file system actually. Okay, this is what exactly it's going to happen in our Hive architecture. And also you can see one more thing here is, as you know, simply what we are going to do, we are going to have our HDFS layer, right? HDFS, this is your HDFS file system. In top of the HDFS file system, simply you are building one more grid kind of thing actually. Okay, you're going to build one more grid kind of thing, so that this is going to give you the better idea. This is going to give you the clean structure for your data actually. Simply once you put the data into this is called your Hive actually. The creating the grid is nothing but your Hive. On top of the HDFS file system, your underlying data will be stored in your HDFS file system only. Whatever the concepts that you have from the HDFS side, still you can see the same thing. So once you put the data here, you are going to just process the data using your Hive queries actually. That is very simple. Okay, so that is what exactly. But as you know, when you are going to create the databases, when you are going to create the tables, when you are going to create the columns within that one, you have to maintain them in a particular place. The definitions of your databases, your tables, and your column names, and anything that you are going to store it, you have to maintain it one place. That place only will be calling as a Metastore. Metastore is the place where we are going to store the Hive tables definition. That is the kind of metadata how we see from our name node. Exactly we are going to see from the Metastore actually. Metastore is the place where we are going to store our entire Hive tables definition. Your Metastore can be embedded Metastore, which means by default your Apache Hive is going to use the Derby database. You can just go ahead and use that one as a Metastore, or as you know, when you are going to use as a Metastore as a Derby database, here there are some limitations actually, where only one person is going to be the only single machine, only in the entire one machine only you are going to have Hive as well as the Derby database. So Derby database is a RDBMS database. It's a it's a file oriented database, and whenever you're going to use Derby as a database, actually you can open only embedded database indirectly, which means everything is going to run in a single machine. So indirectly you cannot open more than one Hive session actually. If you're trying to open more than one Hive session, you're going to see some error actually. For that you can just go ahead and use the standalone one. What I mean by standalone one is, like, you are going to separate, you're going to run in a different machine your Metastore, and you're going to just to do the back and forth whenever you fire the queries. That connection will be made to the Metastore. And here, since you're going to separate your Metastore out of your this embedded one, obviously in the local we'll be calling as a standalone. Metastore is a standalone. So in that case, your query will just be in the with touch with your Metastore. And also you are going to just, you can open more than one session in parallel actually, which means that the table that you have created, I can see, I can access from my side, and the tables which I have created can be accessed by others also. That is all about the Metastore. That is the complete architecture of the Hive actually. Okay, and more on Hive actually, and what and all we can see on Hive actually, what are the advantage that we are going to see on top of the Hive actually. So basically Hive is going to accept, or Hive is very well is famous for creating the simple tables. Simple tables are going to give the lot of difference for our Hive actually. When you're going to put the table on top of the Hive warehouse, it's like it's going to just give the, it's a column names, and whatever the primitive data types, whatever the complex data types, you can just go ahead and use them. On top of that one, simply you can just fire the queries that will be converted into the series of MapReduce programs. So simply you can go ahead and create the tables, and also you can apply the partitions concepts also. What I mean by partitions here is, partitions are nothing but just organizing your table in a structured way, which means, as you know, in the big data world, when you are going to have the data, tons of data you are going to store in a single table, then to just search your data, probably this is the data that I'm going to have, probably last 1 year of data. Out of last 1 year of data from the data source, probably I need only probably last 3 months of data. I'm caring about only last 3 months of data. I don't care about last entire year of data. But using your normal tables, you cannot just process only the 3 months of data. Your search query is going to process from top to bottom actually, sequentially it's going to happen. But if you are going to apply the partitions concept, you are going to divide your entire data into multiple partitions, and you can just, your query can directly come and fire on top of this portion of the data, so that we can unnecessarily, which I don't want to process any unwanted data, which we are going to avoid using the partitions actually. The next thing is buckets, which is very unique concept here. Bucketing is nothing but again dividing your table into equal number of parts, and you are going to store the some amount of data here. So we are going to see some advantages of out of the buckets over the partitions, but you can apply on top of the table, you can apply the partitions, you can apply the buckets also. Buckets are basically is going to follow the hash partitions, which means like if you are going to divide your table into 250 buckets, and which means 250 parts you are divided based on the bucketed column that you are going to store have in that at the time of designing your table. You are going to just see that what is the bucketed column value. Based on that, it's going to perform the hash partitions, and it's going to go and into store into that partition bucket actually. So bucketing is very famous for sampling of your data, which means like instead of processing your entire data, you can just go ahead and sample your data for your probably sampling purpose. You wanted to introduce some of these so and so things, you, instead of just searching your query on top of your entire data, even in the partition also, you don't want to go with the entire partition data, you wanted to go with the only portion of the data. In that case, bucketing is going to be very useful for us. And joins, map joins is going to be very famous out of the buckets actually. Using the map joins, using the buckets, you can join your two tables very nicely without triggering the reducer actually. We are going to see all these things in our classes very thoroughly. Okay, and the physical layout, as you know, like I said, end of the day our Hive also is going to store our data in a HDFS file system. So these are default location of warehouse for our Hive actually, user Hive warehouse. So you can have the different location also, we are going to see in our classes very thoroughly. Okay, and the table data stored in a subdirectories of the Hive. So after this one, whenever you are going to create the database, your database name and your tables name, so your tables name something like that will go on. So you are going to create the subdirectories on top of the HDFS file system actually. Okay, and the next thing here, your default warehouse location on top of the HDFS file. This is your HDFS page, as you know here, and I just browse my file history, and you can see this is where we are going to create the databases. This is my database name, and within that only it has created one directory. This is a directory. You can see this is the directory, and this is the permission, and directory does not have any replication. So whatever the data again you are going to store in your HDFS file system using your Hive, again the HDFS, whatever the concepts that you have out of the HDFS, your Hive data also, Hive tables data also is going to follow the same thing. The replication factor, the block size, and everything will be remains the same thing actually. Okay, thanks for watching this video. See you soon. Thank you.